at aldehyde and ketone. So this aldehyde is otherwise called alkanal. I hope you know. This aldehyde can also be called alkanal. Yeah, the alkanal. While the ketone can also be called alkanone. Alkanone. Okay? So they are a class of organic compounds. The formula for this one is CnH2n plus 1 dot C double bond oxygen single bond H. Where this is R, so we can have it as R C double bond O single bond H. It can also be written as RCHO. So all these are the ways you can represent alkanal or aldehyde. Okay. Then for ketone, the formula for ketone is CnH2n plus 1 dot C double bond O dot CnH2n plus 1. Okay, where these two n's represents R. So we have R C double bond O. Okay, so this R alkyl group must be here. Sometimes this alkyl group can also be a benzene or an aromatic group. Okay, it's still an alkanone. Okay, so you can represent it as RCOR. So these two R might not be the same, so we use prime to differentiate it. So, but they have one thing in common. These two compounds have one thing in common, and that thing is called the carbonyl group. The carbonyl group. So what you have here is what we call the carbonyl group. Carbon that is double bonded to oxygen is called a carbonyl group. So the presence of the carbonyl group, the reactions in these two functional groups takes place at the carbonyl groups. Okay. So the difference between the alkanal or the alkanone is in the what? In this point of carbonyl group. The carbonyl groups in the aldehyde are connected to two alkyl groups. Okay. Sorry, are connected to one alkyl group and one hydrogen. Okay. Also, in this alkanal can, the first member of this alkanal can also might not have any alkyl group, such as this. This is the first member of this group. So the alkanal functional group doesn't necessarily mean that it must contain hydrogen. Okay, sorry, alkyl group. It can contain just two hydrogen from here, and then but it must have the carbonyl group. But the alkanone or the ketone must have the alkyl group present between the carbon to oxygen double bond. So take note of that. Take note of that. So this carbon to oxygen double bond here is sp2 hybridized. Take note. It is sp2 hybridized. It is sp2 hybridized. So what it means is that these two molecules are at this point they have an unsaturated point here. So what is likely to happen between the reaction likely to take place here is an addition reaction. Okay, something will be added to both sides so that the pi bond can leave during the reaction process. So alkanones or aldehyde and ketone, they are treated the same because they have what we call the carbonyl group in them, which is a unique property and that is where the reaction occurs. Okay, so take note of that. So we're going to look at the reactions on the physical and the reactions and the synthesis, so you understand more about these aldehydes and ketone.